Number 2, part B, it asks to calculate the force reading in the spring scale. And the spring scale is attached to the little string here. So basically the reading on the spring scale should just be the tension and the strength. So we have to find this tension. We know the rod's in equilibrium, which means two things. It means that the net force on the rod has to be 0, and also the net torque on the rod has to be 0. So we kind of need to decide which of those we want to use. There's only one thing we need to find, which is the tension. If we tried to use net force, we have two unknown forces. We have the tension, and we also have the force from the hinge. If we tried to use net force being 0, we have too many things that we don't know. But if we use that the net torque is 0, what we can do is, since the rod's in equilibrium, we can put the pivot point wherever we want to, and then say the net torque about that point has to be 0. So if we put the pivot point right here where the hinge is, that way a force that's happening right at the pivot point doesn't create any torque, so we don't need to know anything about that, and then our only unknown is the tension, and we can find the tension that way. So we're going to use the fact that net torque is 0. So if this is our pivot point, we can ignore this force. We have the weight of the rod and the weight of the block making the rod want to rotate this way, and then we have the tension force making it want to rotate this way. So basically, the torques from these two forces together, the tension has to create a torque equal to that to cancel both of those out. So I'm going to write the torque from the tension has to be equal in magnitude to the torques from, we'll say, weight of the rod and the torque from the weight of the block, just to kind of organize what I'm doing. So each torque is RF sine theta. So the torque from the tension force, R is the distance from where that force is happening to my pivot point, which is the length of the rod, which we know is 0.6. The force we don't know, but we're calling it T for tension. And then this little angle between R and F, it tells us is 30 degrees, so we would have sine of 30 degrees. And then that has to equal the sum of the torques from the two weights. So weight of the rod, the distance from pivot point to where that force is happening is half the length of the rod, so 0.3. The force is 2 times 9.8 mass times g. And then that, your r vector and your force vector are just perpendicular, so we don't need to do sine of 90 because it's just 1. And then we have the torque from the weight of the block. So its R would be 0.6, the full length of the rod, times the mass of the block, which is 0.5 times 9.8. And then we just solve that and we can find the tension.